how the cell goes. So this time we will be talking about the cell notation. So instead of drawing all the components of the cell, we are going to use an abbreviation to represent the cell or the voltaic cell. Now the reaction in a voltaic cell is usually abbreviated using a cell notation, and this cell notation is composed of the essential information, or it contains essential information on the composition of the voltaic cell, and the structure is already provided. So in writing a cell notation, the components of the half cell are represented by their chemical formulas or element symbols. So represented by the chemical formulas or the element symbols. And then the boundary between two faces in a half cell are represented by a single vertical line. So kung like for example solid and liquid or liquid and gas, so the chemical formulas are separated by this single vertical line. And then if there are more than one component in a single phase, they're separated using a comma. So usually like for example, ang isa kay liquid and then ang isa kay, say for example, duha ka liquid or duha ka solid or duha ka gas, or maybe even liquid in an aqueous solution, because diba, if you see a subscript L and that's aqueous, so L meaning pure siya, liquid form lang siya sa substance, but if it's aqueous then it's the substance is dissolved in water. But still, even if this is aqueous and this is L, liquid form raman pod siya. So we just put a comma there. The salt bridge is represented by two vertical lines. So we use two vertical lines for the salt bridge. And then the anode reaction is written on the left side of the salt bridge, and the cathode reaction is written on the right side of the salt bridge. So if this is the salt bridge, then unsa may reaction sa anode, that's oxidation. So we put the oxidation, not really the reaction, but the components in the oxidation half reaction. And on the right side is the cathode reaction, so that's reduction. So the components of the reduction nga half reaction. So here we go back to the zinc and copper. So we recall that zinc was oxidized and copper was reduced in the reaction. So what we have here is zinc, so the oxidation of zinc and the reduction of copper. So this is the reaction at the anode, and this is the reaction at the cathode. So we start with our vertical line, double vertical line to represent the salt bridge, and this reaction at the anode, kaning reaction sa anode, mo ni ibutang sa left side. O kaning reduction, mo ni ibutang sa right side. But instead of writing this half reaction, we just look at the components. So we have here zinc, diba? Solid nga zinc og aqueous nga zinc. So this is already, the zinc ion here is already in the solution. So Zn, so that's solid, the oxidation number is 0, and then it loses 2 electrons to form the Zn2 plus ion Aq. No? So this is solid and this is Aq, so they have in different phases. So we put a single vertical line to separate ang mga phase. And sa cathode nga half reaction, so we have copper 2 plus nga ion in the solution, so it will accept 2 electrons to receive to form the solid copper. So ang Cu2 plus nga Aq, so modawat siya electron, so mo form siya og solid nga copper nga solid. So this is Aq and solid, so we're going to use a single vertical line for that. So that would be our, so that is our cell notation for the reaction, or for the overall nga cell nga reaction. So kani siya, muni siya ang cell for this reaction. So instead of drawing katong na half cell, unya na atong salt bridge. So instead of drawing this one, so kani siya, instead kani, so we just write the cell notation. Okay? So voltaic cells can be set up for many different spontaneous redox reactions. So in the previous nga katong example, in the previous page, ang gigamit kay mga reactive nga mga electrodes. But recall that not all the time nga ang electrodes kay reactive. Ano man, some voltaic cells use inert electrodes if the species that participates in the reaction is not a conducting metal. So kung metal man siya, dili siya metal, dili siya, for example, solid, like for example, liquid siya or gas. So it's impossible nga mahimo ni siya nga pwede siya gamiton nga electrode. So the electrode must be solid. So that's why we use inert electrodes para mo take place ang reaction. So let's consider the following reaction. When a chlorine gas is bubbled through an aqueous solution of sodium bromide, chloride ions and liquid bromine are the products of the spontaneous reaction. So, kung chlorine gas ko no, so if there is a direct nga reaction between the two, so kung naa kay solution nga naay sodium bromide, unya ibubble diha ang chlorine gas, so mo produce siya chloride nga ions o liquid nga bromine. So actually, this is NaCl, no? So we can see in the reaction here that the oxidation number of chlorine is 0, sodium is positive 1, bromine is negative 1, and then this is negative 1 also, and then bromine is 0. So naay changes nga ang chlorine ni go from 0 to negative 1, so ni decrease ang iyang oxidation number, so meaning ni undergo siya og reduction. And that bromine, negative 1 to 0, there is an increase in its oxidation number, and therefore it undergoes oxidation. So, wala na nakita nato si sodium sa product. Actually, anhin siya ni chlorine. So, mahimo na siyang sodium chloride, no? So, from the given equation, we can see that chlorine undergoes reduction and bromine undergoes oxidation. The participating substances in the reaction are non-metals. Therefore, an inert platinum electrode is used to allow the flow of electrons. So, diba? This is chlorine gas. And then this is also aqueous, sodium bromide. So, wala gyud solid nila. So, walay solid. So, therefore, gamitan gid siya og inert electrode. And nganong platinum? So, platinum is, it's either platinum or gold nga gamiton as inert nga electrodes because they are kanang dili kay sila reactive. So here, the reactions of the electrodes are, so diba, si bromine ni undergo og oxidation og si chlorine ni undergo og reduction. So kung sa kuan pa na siya, kung i-drawing pa na siya nato sa ato ang galvanic cell, so nani siya solution diri. So unsa may mabutang nato sa anode, ang bromine. So naay bromide nga ions diri. So mo ni siya naay sodium bromide diri dapita initially. Sodium bromide. And then here natay solution, but this is chlorine gas man. So kung bromine ang nasa pikas, naa sa left, ang bromine ang nasa left, dapat si chlorine naa diri sa pikas. But this is a gas man, so kinahanglan siya i-bubble. So, mura good kag, for example, na ay tubig niya imong buwan sa imong baba, di ba? Makita man na nato. So, mura, for example, na ay hose nga i-immerse din ha sa liquid niya pagkahuman, dito ra paagion ang gas. So, it's like that. So, i-bubble through diha ang chlorine gas. So, meaning na ay solution already that's containing the chlorine nga element. So, for example, kani siyang naadri sa left kay sodium bromide na siya nga solution. So, pwede sad nga kani diri sodium chloride. Okay? So, because they are, after na to ani kay bromine ra ba? So, para na reaction, kinahanglan tag electrode. So, insertan siya dihag electrode. Inert na electrode. So, naka-inert na electrode din ha. So, napod kay inert na electrode din ha. But usually, naana siya agianan. So, naana siya buslot para din ha mo agi ang chlorine gas. So, bilang kayo, you will see a picture of this. Or if you've read the notes already, you will see nga na ay special nga setup ana niya. Okay, so ibubble through din ha ang chlorine gas, Cl2. So of course na ay external nga circuit, so din na siya maagi. So this is the inert nga electrode, and of course you still have to connect the salt bridge. So when the bromide ion loses electron, when the bromide ion loses an electron, so mo produce siya og bromine nga liquid. So asa man pad iniglose ani niya og electron, asa man padong ang bromine nga liquid, anhi ra diri sa solution Br2. So duha na siya diha, NaBr nga AQ ug ang Br2 nga liquid. Okay? So kani siyang Br sa sodium bromide, magsige na siya og loose og electron to produce the bromine nga liquid. And then ang diri pud sa pikas kay naman kay NaCl, so ang chloride nga ion dinhi sa left, magsige pud siya dawat sa electrons gikan diri, magsige siya dawat para mo og chlorine nga gas. So na siya bubbles din ha. Okay. So therefore, the reaction on the left side is this one, and then the reaction on the right side is this. Kani. Kani reaction diri sa right side. And then adding the two, so we will get the overall cell reaction. So instead of writing this, instead of drawing this cell, galvanic cell, we can just write the cell notation. So for the cell notation, you can start with the salt bridge, and then sa right side, ang chlorine, I'm sorry, dili man siya mudawat, no? Ang chlorine gas, mo'y mudawat og electron para mo form og chloride nga ions, sorry. So, si chlorine gas, that's a gas, it will accept electrons to form chloride ion. That's AQ. So it's a gas, and then it's AQ, so different nga phases, so we are going to use a single vertical line. And because gigamitan pa siya og platinum nga electrode, so of course that's a solid, so we're going to use a single vertical line for that. On the left side also, so you start with the bromide ion, which is in solution, and then after losing 2 electrons, it will produce a bromine nga liquid. So this is what I said ganiha nga aqueous and liquid. So liquid in form sila, although the other one is not pure, but still in liquid form. So same na nga siya nga phase, so we're going to put a comma. And we use a platinum nga electrode, so that's solid. So that is our cell notation for the given nga overall cell reaction, the reaction between bromine and chlorine. Okay? So this is how it looks like. So muna siya ang naay inert nga electrode kani. Ipagaman diri ibabol ang chlorine nga maoy mo lose og electrons to form the chloride nga to accept the electrons to form the chloride nga ion. And of course, the salt bridge, we must remember that the purpose of the salt bridge is to maintain the balance of the charge on both sides. Alright, so using cell notations, we can write the half reactions and the overall balanced equation of the cell. So, pwede sad nato balihon. So this time we are given the cell notation, and we can predict kung sa overall cell reaction based on this. So we can see, diba? We can see nga ang kani mo ni siyang sa anode ug kani siya mo na sa cathode. And take note also that in the given cell notation, wala na niya gibutang kung unsay phase. So understood naman na siya nga kung metals, they are solid, and then in forming ions, so they go into the solution. So sa anode nga cell, so we have the aluminum, that's solid, Nya pagkahuman sa anode unsa man na siya, di ba, ni lose yung electron. So mo form og aluminum nga ion in aqueous solution, and then ni lose pila ka electrons, 3 ka electrons. Nganong 3 ka electrons man, di ba 0 ang oxidation number ani. Nya 3 plus ni siya. So para mabalance ang charge, dugangan nato og 3 ka electrons. And sa copper nga side, so ang copper 2 plus nga ion, that's AQ. Reduction man ni siya, so mudawat siya og electron to produce the copper metal nga solid. So 0 ang oxidation number ani niya, and then we have 2 plus here. So we add electron on the more positive charge, o pilay idugang 2 electrons. Okay? And then the overall cell reaction therefore would be, so we multiply this equation by 2 and we multiply this equation by 3. So we can just write directly that this is 3Al, that's solid, plus that's 2. That's 2Al plus 3Cu2 plus AQ, producing 2Al3 plus AQ plus pila ni siya, this is 3Cu nga solid. So na-cancel na to ang electrons. Okay? And then so may pormaan na niya sa kuan. Kung atong i-drawing ang galvanic nga cell, so active na siya nga electrode. So active na siya nga electrode, na ay voltmeter din ha. And then we have the salt bridge, solution. So this is the copper nga cathode, and this is the aluminum nga anode. And when the reaction takes place, electrons flow from the anode to the cathode, and then as aluminum loses electrons, so mo form siya Al3+, and then ang Cu2+ diri maoy mo dawat sa electrons to form the solid copper. So ma-use up si aluminum ug mobaga si copper in the reaction. Next, so we have here silver and tin. So as we can see, this is silver that is solid, and then mulu siyag electron to form a silver ion in the oxidation nga half reaction. And then we have tin 4+, meaning it's in solution, and then we have tin 2+, which is also in solution. So the reaction sa anode is Ag, that's solid, losing an electron to form Ag+. So the charge is plus 1, so 1 electron. And then ang Sn nga 4+, stanic, that's Aq, it will accept 2 electrons to form Sn2+, tannous nga ion. So it just means that it's using a platinum nga inert nga electrode because unsa man ni siya, so actually this shouldn't be a vertical line, but it should be a comma here. This should be a comma here because both man aqueous sila nga solution. So Sn4+ plus 2 electrons to form Sn2+, which is also AQ. So wala siya ilabot sa pag-write sa reaction because gigamit naman siya para mo happen ang reaction. So for the overall cell reaction, we're going to multiply the first equation by 2 and add the 2 equations. So 2Ag na solid plus Sn4+ AQ, producing 2Ag plus AQ plus Sn2 plus AQ. And just also remember nga, even if we're just writing the reactions here, so you also need to remember the guidelines in balancing equations. So check gihapon nato, duha ka silver and isa ka tin. The total charge here is positive 4, and the total charge on the left is also positive 4. Third one. So as we can see here, ni-use siya og platinum nga electrode on both sides because sa man siya all are in liquid form, aqueous, no? So ang sa left side, we have iron. And on the right side, we have manganese nga ni change ang oxidation number. So Fe2+, ferrous ion loses an electron to form Fe3+, ferric. So Fe2+ Aq to Fe3+ Aq, meaning nawadaan siya og isa ka electron. And then we have here MnO4 negative, that's Aq. And we have Mn2+, that's also Aq. So we must remember na siya oxygen, we need to recall how to balance the reactions. So we add here 4 ka water, that's liquid, plus we add here 8 ka hydrogen, that's Aq. And then to balance the charge, we are going to add as may more positive ani. So the total charge here is positive 2, and then the total charge here is positive 7. So we're going to add 5 electrons. So we're going to multiply. So 5, let's try to check. 8 ka water, 8 ka hydrogen, 4 ka oxygen, ug isa ka Mn. Alright? So next is to make the number of electrons equal. So we have to multiply the first equation by 5. So 5 Fe2+, that's Aq. And we don't do anything to the second na equation. We just copy 8H plus Aq, producing 5 Fe3 plus Aq plus Mn2 plus Aq plus 4 H2O liquid. So let's try to check. We have 5 ka iron nga atoms, isa ka manganese, and then 8 ka hydrogen, and 4 ka oxygen. Okay? The total charge on the left is 10 minus 1, that's 9 plus 8, that's a total of 17. And here we have 5 times 3, that's 15 plus 2, and that's a total also of 17. So this is our overall cell reaction given this cell notation representing the galvanic cell where these two half reactions take place. Okay, next, draw a diagram for a salt bridge cell for each of the following reactions. Label the anode and cathode and indicate the direction of the current flow through the circuit. Write the half reactions occurring in each half cell and write a cell notation to represent the cell. So, sa unaw na ito buhaton. Sige, let's try to mag-drawing taog kuan. Sige, so muna siya ato ang 2 half cells. Let's draw this again. Okay, so naatay. So as we can see, it's very obvious that the electrodes are active. So there is a plug here. And then it's immersed in a solution. Okay, so the anode is unsa may nahitabo ni zinc. Ni increase yung oxidation number, meaning that's oxidation, and cadmium kay ni decrease ang oxidation number, meaning that's reduction. So our anode is the zinc and our cathode is the cadmium. Okay? So as the reaction takes place, zinc will lose electron to form Zn2+, and the cadmium 2+ in the reaction will go here to accept the electrons given up by zinc. Okay? And then ang cation in the salt bridge will go to the cathode and the anion will go to the anode. So, ningon siya, label the anode and cathode, indicate the direction of the current flow through the circuit. So, this is the anode and this is the cathode. Write the half reaction. So, the half reaction here is Zn, that's solid, to Zn2 plus Aq plus 2 electrons. And the half reaction here is Cd2 plus Aq plus 2 electrons to form Cd nga solid. And then write a cell notation to represent. So Zn solid to Zn2 plus Aq. So we're going to use a single vertical line and then at the anode, and then 2 vertical lines for the salt bridge, and then the Cd2 plus Aq, single vertical line forming Cd nga solid. So this is our cell notation for the given galvanic cell.